Yes, so I'm Francesco Ulloa. I am postdoc here, and I am working with Clem and with Lindsay. And today I will introduce you to the Discovery Project. The title of this Discovery Project is Linking Terrestrial and Aquatic Carbon Fluxes to Rectify to Update the Australian Carbon Balance. So first, we're going to talk about the main scientific objective. But before of that, I need to explain why it's important, this project. So the current Australian carbon balance doesn't take into account the aquatic carbon spore. What's the aquatic carbon spore? Is the spore from the land to the ocean of the carbon through the inland waters. So mainly the rivers. So we know most of the carbon is stored in the land thanks to the vegetation, and there are some ways to return the carbon to the atmosphere, for example, with the fire. But there's also another process, like the aquatic carbon spore. So it's around 1.9 petagram of carbon per year are exported from the land, and only 0.9 arrive to the ocean. But why only 0.9? Because the rivers, they are not only kind of pipe, they are some process in the rivers, as for example, the carbon gas emission and some storage in the sediment in the river. So the aquatic carbon balance doesn't integrate all this process. And also, but why is the reason why they don't integrate this aquatic carbon balance sport? Is because there are very few observations, and mainly in the headwater stream. So what's happening if we don't take, for example, the carbon gas emission? It means the CO2 and methane released by the rivers, which return to the atmosphere. If we don't take this, for example, we are going to overestimate the greenhouse gas reduction by ecosystem. So in this context, our first objective is to build a national database of aquatic carbon sport. Then we are going to integrate with the terrestrial carbon. The terrestrial carbon, we are going to get this data with using the data from the TERN observatories. So here in the map, we have the different super sites in Australia. So all of them, they have a flux towel, and with the flux towel, we get the terrestrial carbon. So once we get the terrestrial carbon and we integrate with the aquatic carbon, we are going to predict at the national scale, the stream carbon sport and use it to update, to rectify the Australian carbon balance. The team, myself, but there are a lot of people like Clem, for example. Also, we have partner in US, David Madman in Sweden, Marcus Wallin, Lindsay, and also in Monash University and Cicero at Canada. So how are we going to reach all these objectives? First, I present the general approach. We have three different levels. The first level is only the Australian tropics. The second level is the Australia, but only the TERN side, the flux tower across Australia. And the last level is the entire Australia, but only with modeling. The two first is with field sampling. So we have two types of measurements. From one side, we have the spot and seasonal measurements. We measure the different carbon species, like the CO2, methane, PIC, dissolved inorganic carbon, dissolved organic carbon, POC, particulate organic carbon, and also the K parameter. This is an indirect measurement of the turbulence in the river, and it's very important because it will control the methane and CO2 evasion from the rivers. We have also water quality parameters, conductivity, dissolved oxygen, temperature, pH, stream geometry, velocity, and discharge. And from the other side, we have the high frequency temporal measurements. Every 5 minutes, we measure the water level, the CO2, dissolved organic matter, dissolved oxygen, conductivity, temperature, and the barometric pressure to correct the water level. So it's not there. Well, it's the real car, 4-wheel drive, but it was a training. It's not like this when I go to the field. And of course, we have some data from the literature. So to start, regarding the hot spot, we have a spatial sampling of headwater only across Australian tropics. So for that, we have done a spatial sampling between March and April 23 during the wet season. And all the circle we can see here are the different stream waters we sampled during this field work. So it was 96 tropical stream sample in less than 3 weeks, and we drove like 10,000 kilometers. And we have some results of DIC, dissolved inorganic carbon, dissolved organic carbon, and isotopes of DIC and DOC. So we can see a variability between the different places. And we are planning a second field sampling in September 23 during the dry season. So just to give an idea, I think most of you know Rexy. Rexy is working in a similar project, but his work is mostly in the Australian tropics, and he's working with the CO2 and methane. So this is his PhD project. So because we overlap, because I'm also working at this scale, we have some, for example, we went together to this field work, but this postdoc project go a bit farther until the entire Australia. We have more spatial sampling, but just here using the flux towers across Australia. So our next, well, the next is in September, but the following is in between November and December around Melbourne and Tassie. The next one is next year around March and Alice Spring. And the last one is here in August 24 around Perth. And we are going to get some data also from the papers. So all of that is like to focus on the hot spot. Now we change to the seasonal hot moments. So for that, we have a monthly sampling campaign across selected rivers in the tropics. So we have selected 2 rivers close to the flux towers, the flux towers of Lynchfield and the flux tower of Roxham. So every month I go to the field and take water sample and download the data. And it's similar in Roxham. I don't go every month to Roxham. It's a local partner who is working in James Cook University who is doing that for us. And if we increase the level, we change the level to the TERN site across Australia, we have also local partners, and all the pink dot we can see. And Alice Mulga is the name of the TERN tower. Voyaging is the name of the TERN tower, flux tower in Perth, and the same Wombat, Warra, and Cumberland. So for example, our local partner in Warra, he already have done the sampling in this place, and we are communicating with the other partner in the other cities. And in addition, we have a high frequency every 5 minutes, but it's only in the Australian tropics. So in the same Education Creek, which is close to the Lynchfield flux tower, and Roxham Creek, which is close to the Roxham flux tower. So okay. So in Education Creek, I showed the monitoring station. This is the monitor station in Education Creek. It's composed by different sensors: CO2 sensor, dissolved oxygen sensor, dissolved organic matter sensor, conductivity, temperature, and water level. All of them, they are protected by a PVC pipe here in the river, and they are connected to the data logger. We have a solar panel, and we already have some data since November 22. So it wasn't me who installed, it was Clem who did that. Because of that, we have missing data here. Yes, I am. So, but we have all these parameters. So here, just the example of the PCO2, the dissolved organic matter, and the dissolved oxygen. And we can see here, it's not only install the parameter, we need to correct the results. For example, in blue, this is the CO2 in the water. In blue is the raw data without cleaning, and in green is with cleaning. So there is some drift and also some outliers. And the same for the dissolved organic matter and the dissolved oxygen. The similar configuration in Roxanne Creek. So we have the 5 sensors. Here are all the sensors, and they are connected to the data logger. Here we don't have a solar panel because the forest cover is very high, strong, high. So we use lithium battery. And the same, since April, we have some data, and the same, the parameter we can see there. And this is an example for temperature, dissolved organic matter, and conductivity. His Rex is a bit tired because he got the virus. So I mean, even if he was sick, he came with us and he helped a lot. And once we got all this aquatic carbon, we are going to integrate with the terrestrial carbon. And our final objective is to predict the carbon export across Australia. And because I was supposed to have a talk of 10 and then 15 minutes, so I add some slides. And we have an additional level only at the Lynchfield Park, at the Education Creek and Lynchfield site. And this wasn't considered in the project, but after discussion with Clem or with other colleagues, we come up with some new ideas. So for example, in this case, we are going to study a high resolution spatial sampling along the creek. So this is the creek. This is the Education Creek. We have an upstream monitoring station. We have a second one, downstream monitoring station. And we are going to study along the creek. So in this case, we are going to have additional data because we are going to study also the soil water. So for that, we are going to install piezometers. Where is the red line? We have 2 piezometers per each red line. And why 2 piezometers? Because 1 piezometer is going to be installed in the riparian area to study the input, carbon input from the riparian area to the river. And the second one is going to be installed in the upland area to find the difference between the input coming from only from the riparian and from upland. Also, the different dots here represent the different cascade, very small cascade, but they are very important for the gas evasion. So we are going to study the influence of all these cascades over the gas evasion. So there are only 2 ideas we have in addition to the project, but we also have ideas about the metabolism, the gas emission, but I don't have enough time to present all of that. But it's just to show we are bringing something else to the project. And that's all. Thank you. Thank you very much for your kind attention.
Thanks, Francesco. That was great. Can you tell us about the role of fire in carbon export? Because presumably it does play a big role through whether charcoal, ash, or how does that work?
The fire have a great impact, especially in Australia, where the fire is very common. But and they take in consideration here, for example, there is one map where they calculate the carbon balance, and they take. So the problem is not the fire, because they take in consideration the return of the CO2 to the atmosphere. The issue here is they don't take into account the aquatic carbon export. But yes, in Australia, when I saw the carbon balance, a big part of the return to the atmosphere comes from the fire.
Yeah, no, I was thinking in terms of charcoal being exported through, in the streams and into the oceans, because presumably that's a big deal here in Australia. And so I presume the carbon measurements that export includes charcoal and ash. It's not.
Yeah, but knowing the way of charcoal is because we are going to measure the dissolved organic carbon and particular organic carbon. And I believe during the fire, we are going to see high values of this species of carbon, and they are going to be related to the fire.
Yeah.
Yeah.
Thank you.
Just to complement this answer.
Yeah.
So what we've seen in a few other streams in the area is that the first flushes of the wet, the early storms in the say anywhere from September to December is where you get huge peaks of particulate organic carbon in the stream. So that's probably directly related to all those fire, charcoal, ashes, whatever. So yeah, I think it's really, really important in this project that we try and capture these first flushes, because they will be particularly important for this, all the black carbon. Yeah.
Probably we are going to see in this DOM, dissolved organic matter.
As well, yeah, but it's probably going to be particulate in mostly. Then the bigger, when we say we measure particulate organic carbon, it's still just the suspended sediments. So we're not looking at bigger things, which could also be an important unknown. Yeah.
Yep.
Okay.
Thank you, Chesky. This is a very good presentation. It seems like you've got a good project under you. So just you keep saying that you got local partners helping with the data collection and giving the spatial variability of the different sites you just measuring. I just want to know if at this point you think there's a need, or you already know that you've got a sampling protocol, that.
Yes, SOP, we have a standard operation protocol, and I brought that and I sent them. And in addition, I trained our local partners, because some of a few times they are not in the hydrological science. So I need to explain how to take the samples, because, for example, the CO2, it's maybe not very interesting, but for the DIC, the dissolved inorganic carbon, in some places where it's not carbonated, so we have really small amount, and if we don't take the sample correctly, all the DIC can be evaded. So it's like, yes, I always make sure to have the same protocol, and this because in this way we can extrapolate. Otherwise, they will apply their own protocol, and sometimes they don't know. So yes, for example, last week I had a chat with them, with people in Melbourne. So I explained them.
So again, coming from spatial science, I just want to know what at this point, what is the spatial extent of these fields? Is it like very fine, or you want to scale it up?
Our partners?
No, I mean for the whole project.
So for the whole project, as you saw, there are three levels.
Yeah.
So around, we are going to have like high frequency only for here, but we are going to have these spot measurements here, 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 not here, here, and here. So with these spot measurements, we are going to at the scale at the entire Australia. I mean, we are not going to have dots everywhere, just in some specific places. And we are going to have some hypotheses to upscale, but I think it's something normal, because it's already a huge work to build all these data sets, because there is not data.
Yeah, thank you.
Any other questions, Vanessa?
I'm wondering, because you keep you keep talking about the Australian tropics, but you are kind of forgetting of the Western Australian part. Is it that you are going to do just the tropical NT and Queensland area, or because how are you going to extrapolate to that side if you don't have even a point?
I mean, we're going to have some sample here around.
No, but for the Australian tropics, like you see where the L of Litchfield is?
Yeah.
But just the letters.
That's on this area, this is the
No, but to
Western.
the top.
Ah.
Yeah, that area. That's also tropical.
Yeah, but I mean, when we are going environmental science, we can know take samples everywhere. So we need to focus. It's already, you see, we have a lot of data here, and I know this is tropics, but we are going to need to upscale without having sample here, because it's going to be the same here. For example, we don't have sample here, and we are going to have some hypotheses, of course.
Yeah. Okay.
Yeah. It's just I say.
Cape River. But we'll be heading over to the Cape River, so maybe that's a good opportunity to see on courses.